and welcome to this lesson. Today, we're diving deep into the exciting world of data science, big data, and cloud infrastructure, and discovering how they drive the future of AI ops. Before we begin, let's go over the agenda for this video. In this tutorial, we shall cover: what is data science? How does data science power AI ops? What is big data and why it is important? Understanding large datasets. What is cloud infrastructure? How big data and cloud infrastructure work together. Real-life applications of big data and cloud infrastructure. With that said, let's dive right in. Let's begin by understanding what data science is. Data science is a field of study that focuses on extracting meaningful information from data. It's like being a detective, but instead of solving crimes, data scientists solve problems by analyzing and interpreting data. This process helps organizations make better decisions by transforming raw data into actionable insights. Now that we understand what data science is, let's discuss how data science powers AI ops. AI ops begins by collecting data from IT systems, such as logs, metrics, alerts, and user activity. This data is then cleaned and pre-processed to ensure accuracy and completeness. Data science techniques are then used to identify patterns in the data like trends, long-term increases or decreases in data over time. Anomalies, outliers, unusual data points that deviate significantly from the norm. Correlations, relationships between variables where changes in one affect another. Time series patterns, observing changes over time to make forecasts, for example, stock price predictions. Behavioral patterns, identifying user behaviors and preferences, for example, website navigation paths. Causal relationships, determining cause and effect relationships between variables. When problem arises, data science helps AI ops perform root cause analysis by analyzing historical data and event correlations. This allows IT teams to identify the root cause of issues more quickly, reducing downtime and ensuring smooth system operation. Furthermore, data science enables AI ops to predict future issues and intelligently take action using automation, like allowing IT teams to be alerted of potential server overheats based on past data, or automatically scale up resources in advance of expected traffic spikes. Or restarting a service to prevent a crash when AI ops detects a server running out of memory. This level of automation saves time and reduces the workload for IT teams. So what counts as big data? Big data refers to extremely large and complex sets of data that traditional tools cannot handle efficiently. Think about all the information generated every second, every social media post, like, or comment, every online purchase or search query. Data from sensors in smart devices, like your smartwatch tracking your steps or heart rate. All of this data adds up, fast. Big data is measured in terabytes, petabytes, or even exabytes, which are trillions and quadrillions of bytes. Now let's discuss the 5 V's, which represents the characteristics of big data. 1. Volume. This refers to the sheer amount of data being generated. For example, social media platforms like Facebook and Twitter collect billions of posts and interactions daily. 2. Velocity. This is the speed at which data is created and processed. Think of streaming services like Netflix. They constantly collect data about what you're watching to recommend your next favorite show in real time. 3. Variety. Big data comes in many formats, like videos, images, text, or even audio files. For example, a weather station collects data from temperature sensors, satellite images, and radar systems, all different types of data. 4. Value. Value is the ultimate goal of data collection and analysis. Raw data alone has little significance unless it provides meaningful insights that drive decision-making and innovation. Companies like Netflix use data analytics to offer personalized recommendations, while healthcare organizations analyze patient records to detect diseases early. 5. Veracity. Veracity focuses on the accuracy and reliability of data. Inaccurate, incomplete, or duplicate information can lead to poor decision-making. AI models, for example, must be trained on clean and trustworthy data to produce meaningful predictions. Challenges such as missing values, inconsistent entries, and outdated records must be addressed through proper data cleaning and validation techniques. Data that is accurate, timely, and well processed leads to actionable business strategies and competitive advantages. Now, let's discuss the various ways data can be processed. First, we have real-time data processing. Real-time data processing means analyzing and acting on data as soon as it's generated. Imagine you're shopping online, and you click Add to Cart. The system immediately updates your cart, checks product availability, and even recommends similar items. That's real-time data processing at work. Handling large datasets in real time requires a combination of technologies, strategies, and processes like 1. Distributed systems. Work is split across multiple computers to process smaller chunks of data simultaneously, enabling quick insights. For example, Netflix manages millions of viewers using distributed systems. 2. Stream processing frameworks. Data is processed continuously as it arrives, rather than in batches. Tools like Apache Kafka, Apache Flink, and Spark Streaming handle real-time data flows, similar to a factory conveyor belt analyzing items on the move. 3. In-memory processing. Data is stored in RAM instead of hard drives for faster access, critical for tasks like instant stock trading analysis. 4. Scalable cloud solutions. Cloud platforms, for example, AWS, Azure, Google Cloud, allow dynamic scaling to meet demand spikes and offer tools like Amazon Kinesis or Google Pub/Sub for real-time data processing. Next, we have batch processing as the second type of data processing. Batch processing is a method where data is collected, stored, and processed in chunks or batches at scheduled intervals. Instead of processing data as it arrives, the system waits until enough data has accumulated, processes it all at once, and then delivers the results. Let's discuss the characteristics of batch processing. Bulk processing. This involves handling large amounts of data all at once. Scheduled intervals. This means processing of data happens periodically, such as hourly, daily, or weekly. Slower turnaround. This means results aren't immediate, as processing happens after the data is collected. Some examples of batch processing includes payroll systems. Companies calculate and process employee salaries once a month in a single batch. Bank statements. Banks generate monthly statements by processing all transactions for the month at once. Data analytics reports. Marketing teams analyze campaign data weekly or monthly to measure performance. Now, let's talk about cloud infrastructure. To understand it, let's first simplify what we mean by cloud. When we say cloud, we're not talking about the fluffy white things in the sky. In technology, the cloud refers to a network of servers that store and process data over the internet. Cloud infrastructure is the backbone that makes cloud computing possible. It includes all the physical and virtual components required to deliver cloud services, such as servers, powerful computers that process and store data. Storage, systems where all your files, apps, and data are kept, and networking, the connections that allow these servers to communicate with each other and with your devices. Now that we know what big data and cloud infrastructure are, let's see how they work together. Big data requires enormous storage capacity, powerful computing resources, and scalability to handle fluctuating data. Cloud infrastructure provides a solution by offering scalability, cost efficiency, global access, and advanced tools for managing big data. Let's look at a few examples of how cloud infrastructure is implemented to manage big data. 1. Healthcare. In healthcare, they are used to analyze patient data to improve treatments, use AI to predict health risks, and share information securely. 2. E-commerce. In e-commerce, organizations relies on this technology to analyze customer behavior, optimize inventory and provide a smooth shopping experience. 3. Streaming platform. Streaming platforms use these technologies to recommend content, monitor trends and deliver high-quality streaming. 4. Smart cities. In smart cities, they are used to monitor traffic patterns, improve public services and analyze energy usage. To wrap up, let's quickly review the key takeaways from this tutorial. We began by understanding what data science is, how it transforms raw data into valuable insights using artificial intelligence. We then explored how data science fuels AI ops, enabling automated IT operations that improve system performance, detect anomalies, and enhance decision-making. Next, we discussed the importance of big data, emphasizing how massive volumes of data drive innovation across industries. We also broke down cloud infrastructure, explaining how it provides scalable, flexible computing resources for businesses and individuals alike. Finally, we looked at some real-life applications of big data and cloud infrastructure, from healthcare to even personalized recommendations in streaming services. These technologies continue to shape the modern digital landscape, revolutionizing industries and everyday experiences. Before you go, take your learning to the next level. Click the link in the description to access this lesson inside the MotivaLogic Academy Learning Management System. There, you'll find a quiz for every lesson, hands-on labs, and real-world projects designed to test and strengthen your understanding. While you're there, explore our full catalog of advanced, hands-on courses and downloadable resources, all created to help you move from theory to real-world expertise faster. Ready to gain real industry experience? Work on practical projects, collaborate with other professionals, and build a strong GitHub portfolio that sets you apart and accelerates your career. Click the work experience link in the description below to register your interest. Don't forget to like, subscribe, and share. And turn on notifications so you never miss a future lesson. Thank you for watching.